Good morning, students. This lesson is of class 8th for the subject of physics. Children, today we will be doing the remaining numericals of exercise 2C. You all are required to open page number 54 of your physics textbook titled Concise Physics by Selena Publications. And children, also open your notebook to do the numericals along with. Now children, see question number 11 given in your book on page number 55. So the question is, a body moves from rest with a uniform acceleration and travels 270 meter in 3 seconds. So what we are given in this first line of the question, a body starts from rest. It means that it is starting from rest. That is, its initial velocity will be taken to be 0 meter per second. It travels a distance of 270 meter in a time of 3 seconds. So children, let us find the acceleration in this 3 seconds of time. So let us use second equation of motion, which is S is equal to ut plus half at square. So children, for t is equal to 3 seconds, the distance traveled is 270 meter. So let us put the values and kindly note that time here is taken as 3 seconds. So while solving this equation, we get acceleration to be equal to 60 meters per second square. But question was something else. Children, look at the second line of the question. Find the velocity of the body at 10 seconds after the start. So when you have to find final velocity, you have to take time 10 seconds and not 3 seconds. Earlier, we have already calculated acceleration as 60 meter per second square. But now, let us use first equation of motion such that final velocity is equal to u plus at. Children, right now also, the velocity, initial velocity is 0, while acceleration can be taken as 60 since the body is moving with uniform acceleration. That means that acceleration is not changing. And t stands for time, which we will be taking as 10 seconds. So if we solve, we'll get the final velocity, which is 600 meter per second. Now children, coming to question number 12. A body moving with constant acceleration travels 3 meter and 8 meter respectively in 1 second and 2 seconds. So, a body is moving with constant acceleration. Children, here we will form two cases, and in both the cases, we will be using second equation of motion. That is, S is equal to ut plus half at square. In case 1, I'll take distance as 3 seconds, 3 meter. Distance will be taken as 3 meter. U will remain as it is. T, I'll take it as 1 second. A, again I'll keep as it is. And square of T means square of 1, which comes out to be 1. So children, here the equation becomes C3 is equal to U multiplied by 1, U plus A by 2. So keep u one side and bring a by 2 towards the other side. So since there is a sign of positive here with a by 2, when it goes to the left side, it can be written as 3 minus a by 2. So let us take it as equation number 1. Let it be equation 1. Now let us solve case 2. Again, I'll be using second equation of motion, but distance will be taken as 8 meters. Since it is given in the question that distance is 8 meter in t 2 seconds. So instead of time, I'll take 2 now. Square of 2 means 2 multiplied by 2. So children, let us solve this value. When you are solving it, from the left side, you can take 2 common. From the right side, look at the right hand side of the circled equation. Number 2 is common to both the terms. So let us take it out such that this 2 when is taken out of the bracket, I'm left with only u plus a here. Children, this was equal to 8. Now this 2 is multiplied with the bracket. So when it will be taken on the right hand side, it becomes u plus a is equal to 8 upon 2. That is 4. And what will be the value of u then? Take a also on the right side. So this plus a will change into minus a. You can write this equation as equation number 2. Now children, number 1 equation was also depicting the value of initial velocity, and second equation is also telling you the value of initial velocity. So in both the cases, on the left side, our term is same. In this condition, we can equate the values. That means equating 1 and 2. What do I mean by equating? The right side of equation 1 is actually same as right side of equation 2. Why? Because left hand side of both the equations are same. If u is coming to be 5 meter per second, then initial velocity is same. It will be 5 only. That is the starting velocity. So children, we will be equating equation 1 and 2 such that I can solve for the value of a as shown in the PDF, and I'll get the value of a as 2 meter per second square. Just see, after equating what I have done, I have taken minus half on the right side. The terms with acceleration are taken on RHS, right hand side, while the constants, that is, the term including only numbers, are kept at left hand side. So children, 3 minus 4 is minus 1, and then you take the LCM such that on right side your answer is minus a by 2. That means minus minus cancels out and a will be 2 meter per second square. Now this is the value of acceleration. You can put this value of acceleration in either equation 2 or in equation 1. If you put a as 2 meters per second square, then your answer will come 4 minus 2, 2 meters per second. Children, note that the SI unit of acceleration is meter per second square, while The SI unit of velocity is meter per second. Now children, you all are required to take a break for 10 minutes, and in the meantime, you are required to go through example number 5 given on page number 53 in your physics textbook. So children, pause this session and try to solve example number 5. It is similar to question number 12 which we have done just now. I hope you all have done example 5. Now see question number 13 given on page number 55. A car travels with a uniform velocity of 25 meter per second for 5 seconds. That means the initial velocity is 25 meter per second in time of 5 seconds. And after 5 seconds, the brakes are applied and the car is uniformly retarded and comes to rest in further 10 seconds. So children, first of all, see the first statement. Car travels with uniform velocity of 25 meter per second. Now uniform velocity means, what do we mean by uniform? Uniform means constant. Uniform means constant, which is not changing. So children, uniform velocity means acceleration will be 0. So in the first part of the question, they are asking the distance which the car travels before the brakes are applied. Before the brakes means when time is 5 seconds. So here we will use second equation of motion and substitute the value and take A as 0 while time will be taken as 5. So 25 multiplied by 5, our distance comes out to be 125 meter. While in the second part, they are asking for retardation. Now children, in the first 5 seconds, the brakes were not applied. So what does it mean? The brakes are applied and the car comes to rest in the next 10 seconds. So when we have to find retardation, we will take time as 10 seconds. So children, using first equation of motion, that is V is equal to U plus AT. Don't put A0 here because here the velocity is changing. Final velocity is 0, initial is 25, time is 10 seconds. So here your acceleration comes out to be negative, that is minus 2.5 meter per second square. So thus retardation, the value of retardation is 2.5 meters per second square. And then the third part is find the distance traveled by the car after applying the brakes. So now you have to find distance after the brakes are applied. That means we'll take time as 10 seconds. So children, now put the value of acceleration as minus 2.5 because the value of acceleration was negative. So put the value as negative here. So your answer will come 125 meter. Children, remember that in these questions, your time and distance will not come negative. So just pay attention while putting the sign of negative of acceleration. So yeah, now you all can open page number 53 and read example number 7. You may take a 5 minutes break and try to solve this example in your notebook. So children, in example number 7, a particle is initially at rest. This means that initial velocity of the particle is 0. It moves with acceleration 5 meter per second square for first 5 seconds, for 5 seconds. So the question is find the distance traveled in 4 seconds and 5 seconds. First two are very easy parts. You only have to put the value of t as 4 seconds to get the first answer, and then you have to put the value of time as 5 seconds to get the second answer. But the third answer is find the distance traveled in the 5th second. 5th second means only the last 1 second. That means, suppose children, here as we have calculated the distance traveled in first 4 seconds and the distance traveled in first 5 seconds. So in first 4 seconds, the distance traveled comes out to be 40 meter. So the distance covered was 40 meter. While in the first 5 seconds, the distance covered is 62.5 meter. But now the question is how much distance is covered in 5th second? That means only the last second. Only the last second. So how to find? What we will do? Yes, we will. How to find this blue distance? You can subtract 62.5 meter minus 40 meter. That will be the distance coming in the last second. And your answer will be 22.5 meter. So children, with this, I come to an end to this interactive session. And we have completed the numericals of exercise 2A and 2C. You all are requested to go through the examples also and again practice all the unsolved numericals. Thank you students and have a nice day.